This video shows the multi-source monitoring demo that people from WP4 of the CHOReOS project developed for M24. In particular, with respect to the CHOReOS process model, we will focus on those activities concerning monitoring and SLA verification and violation at runtime. This kind of activity is also related with the work that has been done to the other work packages, in particular work package 2, where the SLA that are we going to use are supposed to be defined and then formalized, and then formalized in different kind of languages, from abstract notation or like Q for BPNM to real contracts like the SLA we are using in this demo. So, summarizing this demo, these non-functional properties, only non-functional properties that can occur at different layers, that each properties can focus on different goals, and we will show how to support the monitoring of this property in order to keep them under observation by coordinating different monitoring activities. With respect to the scenario, our case study is based on the ATFM use case that has been developed in the work package 6. In particular, the scenario number 2, sub-choreography C, that is informally referred as the unexpected arrival choreography in the airport friendly use case. We actually did not deal with the whole complexity of the choreography, but for the sake of the presentation, we just limit our demo to two of these tasks. In particular, a task that involved the ATC and the airport services. So in this case, the ATC asked to the airport services for a confirmation for approaching, for landing in an unexpected way, and after confirm this kind of this landing, the airport service activate another task that's called the booked Amenity, where it interacts with other services like the luggage handling company services, or the security company services, or the Airbus company services. And in particular, in this demo, we just focus in the interaction that will occur between the airport services and the security company services, dealing with the task CH21 booking Amenity. With respect to the code that has been developed by the guys from WP6, we actually assumed that, differently from them, that some of those services have associated a non-functional parameter. As I said before, this kind of SLA has been designed or developed in other tasks of the CHOReOS process model, in specifically with respect to the task developed in the WP2. But of course, this aspect is not part of this demo. We just assume that we have this SLA. And in addition, for the sake of demonstration, with respect to the code they developed in WP6, we added a small portion of code in the services in order to easily introduce violation of SLA. Of course, this is just for the sake of demonstration of this demo. So in this slide, we represent the overall scenario of the the overall architecture we deployed for this demo. So it's quite complex architecture, and in the following slides, I'm going to explain each element of the scenario and show you how they actually run together. So first step is the deployment of two instances of the services, as I said, the airport service and the security service, on two nodes of our infrastructure, and I will show how to activate those instances. So let's go to the code here. Oh, no, sorry. Here, and let's start first the security service, and then let's start the VS airport, so the airport services. So once the service instances are ready, they expose their interface in form of WSDL, and let's check them. Okay, here we go. Okay, perfect. Let's go back to the presentation. So step 1.1, we activate the ESB, that is the core of our infrastructure for supporting the choreography enactment. So all the services are communicating through this ESB. So again, let's move to another server and let's start up the ESB. Okay, that's completed. Let's check it if it's work. Okay, it's there. And let's go back again to the presentation. So next step is to bind the instances of the services to the ESB so that the services can be choreographed. So let's go here to the let's interact with the administration panel of the ESB, and let's let's configure. Let's bind the airport to the ESB, and let's also bind the security company to the ESB. Okay, if we go here to the welcome message of the ESB, we can actually see that the airport client, the airport server, and the security company service has been federated with the ESB. Okay, as a last step, I should also configure properly those services. Okay. Let's go back to the presentation. Now, step number 2 is enabling the monitoring infrastructure. So, in particular, activating the CEP, the complex event processor that allow us to correlate events at different level, and the BSM, so the business service monitoring. So those parts of the architecture they actually collect and analyze events happening on the ESB and trying to match or to identify possible violation of contracts of SLA violation. We should also activate the probes on both the infrastructure level and to the BSM. So note that the probes at the infrastructure level are very different. The glimpse probe are these probes are the elements that send information, they actually send information to the CEP, but their nature is very different. In fact, the probe that is connected to the BSM as the goal of this probe is to send messages at the business service level, while the probes at that we have developed on the infrastructure are mainly focusing in sending information about the status of the status of the infrastructure where the cloud where the services are deployed. So as a first step, let's run the BSM, as it takes a while. Okay, now it's going to be started. I will come back later, and then let's check here the CEP. I actually already started it because it also requires some configuration that are not faster to do in a video demo. Okay, and then let's go back on Brazil and on the machine where hosting our service, and let's run the probe on that machine. Okay, fine. Let's see if the okay, the BSM has been activated, so let's see. Okay, here we go. As you can see, the BSM already export the glimpse probe. Let's go back to the presentation again. So next step is connect the monitoring elements and federate the BSM and the ESB. Well, actually the probes, both the probes at the infrastructure level and at the BSM level has already been connected to the CEP. And for example, from the probe at the business level can be seen here. And okay, so let's federate the BSM and the ESB. So we go in the administration panel of the BSM, and we connect the BSM to the ESB. Okay, the request is made. Let's check. Okay, as you can see, the BSM revealed the services connected to the BSM, so it can analyze events that deals with those elements. Okay, the last step, step 3 of the configuration, is enabling the log knobs of the infrastructure. Those log knobs are actually a means we use for this demo in order to overload the infrastructure where the services are deployed. So in such a way we can create anomalies at the infrastructure level. Actually, those probe are already running. For example, here on Vignedo, we can see that on the port I reported on the graph there is a service running, and so the only thing we have to do according to the slides, the federation, is loading the SLA on the BSM. So the SLA is located somewhere, and it's an SLA that actually says that let me check. Okay, is an SLA about latency that actually say that the security company service should interact with the airport service taking no more than 2 seconds. So the interaction between airport and security company services are regulated by this agreement that should be respected. So let's go again to the administration panel of the BSM, and let's load the agreement. Okay, now going here into the console of the BSM, we can actually see that an SLA has been registered. Okay, the mock-up of the infrastructure is over, so we now can actually run the demo, and we organize this run in two sub-scenarios. In the first sub-scenario, we present a case study when an SLA at the business level happened, and we infer, and as there is no information coming from the infrastructure, we infer that this violation is due to a problem at the business service level, while in the second scenario we show how we actually correlate events happening at different levels. So with respect to the choreography I presented at the beginning of the video, we simulate the ACT services invoking the airport services on the confirmation approach task, so invoking the confirm operation. When this happened, after the airport accepted the confirmation, the airport started interacting with the other services, so for example with the security company, and this interaction takes place passing messaging through the ESB. and when if and when the SLA the data of this interaction are sent, the events of this interaction are sent to the BSM, and the BSM analyze them, and if an SL violation occur, then the BSM through the glimpse probes notify this happening to the CEP. Now the CEP, in receiving this notification, what it does is to start a dynamic discovering process in order to see if there are around some events coming from the infrastructure level, and so it generates automatically a sort of rule aiming at discovering this kind of this event. In this first scenario, we assume that there are no events, and no such kind of events coming from the infrastructure level. So at the end, the CP will infer that the SLA is probably due to problems at the business level, so maybe a wrong implementation of the service or a wrong deployment of the service, but nothing that had to deal with the status of the infrastructure. So let's go to the code. Okay. As a first thing, we simulate the ATC service invoking the confirm operation. Okay, let's see if we got something. Okay, it seems yes. So what's happening? It's happening that okay, the airport service received a confirmation, so he actually processed this operation, and then it activates the elaboration of the following task. So interacts with the security company service, and during this interaction it happened an SLA violation, and the BSM actually verified this SLA violation, so there was a latency violation between okay, let me see if I can wrap. Okay, a latency violation coming from the okay, this is the whole latency violation coming from the security company. Okay. Okay, now what's happened? Happened that the CEP in front of this SLA violation generated automatically a rule that it's able to detect a violation coming from the infrastructure. So you can see here that a new rule has been updated in the knowledge base, and this is actually the body of the rule, where the CEP is looking for an event that is an SLA alert, but also for an event, B event, as you can see here, that came from Viñedo, so the machine where is supposed to be deployed currently the service, the security service. So if this happen, okay, we can infer that something coming from the infrastructure, a problem may come from the infrastructure. If not, this is not the case. So I will point out that this rule has been automatically generated, and as you can see, those elements, like the name of the machine where the service is running, have been actually automatically generated and automatically and dynamically generated by interacting with the ESB. let's see what's happened during the meanwhile we were talking. So in this period, actually no event coming from the infrastructure level has been found, so the CP concluded that probably the SLA violation occurred due to a business level problem of the security company service. So this ends the first sub-scenario. So let's present the second sub-scenario. So in this case, before starting with the interaction with the services, we actually make this little hack, overloading the machine by means of the lock knob, and then in this case the machine starts to have a slower lower performance. But the probes from Glimpse detect this anomaly of the infrastructure and start sending information to the CP saying, hey guy, here we have a problem at the infrastructure level. So when we simulated the SCT service invoking the airport service on confirmation of for a confirmation of landing, and when the airport agrees that, and then it starts to interacting with other services in order to book amenity, like for the security company, those data are sent to the BSM, and if an SLA violation occurs in this case, when the Glimpse probe sends the notification to the CP can start the process we saw before. So it starts to infer a new kind of start interaction with the ESB in order to infer, generate rather than infer, generate new rules that are specifically focused on the machine hosting the services involved in the SLA. So in this case, as this new rule that have been automatically generated matches with the other events coming from the infrastructure level, we can actually infer that the SLA violation possibly is due to some issue at the infrastructure level. Okay, so let's see how it runs now. So the first step we have to do is to activate the lock knob, for example on Vigneto, the machine hosting the security service. Okay. Now the machine is going to be overloaded, and now let's go here and let's simulate again the ATC service sending a request to the airport service. Let's see what's happened. Of course, we should be sure that an SLA violation is going on. Let's see. Probably this is the case. Okay, so if we query again the Glimpse log, we can say that a lot of stuff. Okay, I will wrap this in order to see it better. Okay, first of all, I will show you that the Vigneto is actually has been recognized as the Glimpse on Vigneto as actually pushing some events, saying, okay, this machine has a load that is more than the threshold that was supposed to have, and also I would like to show you that the SLA has been here we go. The SLA has been kept by the BSM, the SLA violation, and this has been sent to the CP. And like we did in the previous sub scenario, the CP automatically generated some rules detecting if there were some messages coming from the machine. So in this case, this is the other rule that has been inserted and into the knowledge base, and it actually predicates on the machine vigneto, and it actually predicates on the service. On the service, what it is? I lost it. On the security company service. So this is the name of the rule. Somewhere should be written also this, but I cannot find it anymore. Okay, but I can find in this other rules. So security company service infrastructure. So actually the CP generate a set of rules that dynamically aims to dynamically discover the violation. Okay, so far so good. We got this kind. We show this, and then we got information notification at the lower level. We got notification of an SLA violation. We generated automatically the rule, and magically the CP actually infer that maybe I need a refresh. I lost it. Sorry, I lost it. I tried to generate another SLA. Okay, maybe this is okay. This is the SLA. Okay, so, and here we go. We got a message saying that SLA infrastructure is due to an overload of the machine, possibly vigneto. Okay, and this happened because the service correlated this SLA with the previous messages from the infrastructure level I showed you. Okay, let's go back to the presentation. So basically, this concludes our demo. So I will point out the main improvements we got since May 18. So we introduced a dynamic discovering of the machine hosting the services. Basically, in the demo at May 18, we consider a fixed mapping within services and the machine hosting them. We added an automatic generation of infrastructure-oriented rules from the SLI we received, while in the rules at M18 were still hard-coding the name of the machine sending the notification. The dynamic adaptation of the rules in the knowledge base. In the previous demo, we had a static map definition of the knowledge base, and we introduced a self-diagnostic at the infrastructure level. So in the previous demo, we had the necessity to introduce a live notification, while in this demo the cluster of the nodes offering the infrastructure services can actually detect when the node is failing, so we don't need anymore the live notification. So this concludes our demos. Please keep following us on www.choreos.eu and on the other social platform we are using. Thank you.